Good evening. We are continuing on with our Unit 7, and this is Lesson 6-7. We're going to move on from our simple probability and go to our compound probability, where we're putting together more than one event. So what is compound probability? Well, just what I just said. Compound probability is where you put together one or more events. We combine them together. We've got flipping a coin or drawing a marble. We've got rolling a dice and picking a card. Or what if I put together an ice cream sundae and I give you all that in front of you? How many different types of ice cream sundaes could you make? What would be your sample solution? What could be a possible ice cream sundae? Well, we're going to use the fundamental counting principle. That is the fundamental counting principle in order to find our solution sets. So the set of all possible outcomes, don't forget, the set of all possible outcomes of one or more events is called a sample space. So we put together a sample space right here, and I put it into a table right here. Event 1 is we are going to draw a marble out of a bag that contains 3 different colors. We have either a blue marble, a green marble, or a red marble. So you have 3 actual options in event 1. There's 3 possible outcomes. I can take my bag and I can either draw out a blue, a red, or a green. Okay, ooh, I got a green. Okay, so second one, we can flip a coin. What can we get? We can get either a heads or tails. So we have a possible of 2 outcomes. Well, if I'm putting those 2 events together, well, I can get a heads with a red, I can get a heads with a green, I can get a heads with a blue, or we can do the same with tails. Tails with a green, tails with a blue. So how many total possible outcomes do we have here? Well, total, we have 1, 2, 3, 4, 5, 6. We have a total of 6 possible outcomes. Is there a faster way to do it? Well, maybe instead of a table, we'll try a tree diagram. Tree diagram works a lot about the same. So we have event 1 and we have event 2. And we want to see how many different ways we could make each event happen. So we can sit here and we can go red and heads. So we'll just do kind of what we did before. We can go red and tails. We can go green and heads or green and tails. We can go blue and heads or blue and tails. How many total possible outcomes? 1, 2, 3, 4, 5, 6. We have 6 possible outcomes in a tree diagram. Tree diagrams are pretty good because you can sit here and you can go, well, here's event 1, so here I'm going to start. Well, I picked a red, then I picked a heads, picked a red, then I picked a tails. We can follow tree diagrams fairly easy. Well, what are we going to do if we come across a problem like this one? Sam's Sundae Shop is having a Sunday special. For $3, you may choose 1 flavor of ice cream, 1 sauce, and 1 topping. Sam's ice cream flavors include vanilla, chocolate, strawberry, mint, and Oreo. He has raspberry, pineapple, and chocolate sauces. The toppings include nuts, sprinkles, M&Ms, and chocolate chips. How many different $3 sundaes can Sam make? I want you guys to pause the video for a second. Pause it, and I want you to try to figure out how many do you think you can make. Then come back, and when you come back, I'll teach you the fundamental counting principle. So we're going to use a tree diagram. Well, we're going to tree out what's our very first event. The very first event is we're going to pick an ice cream flavor. How many different ice cream flavors does he have in his shop? Well, we can choose vanilla, chocolate, strawberry, mint, or Oreo. So we actually have 5 different options for the ice cream flavor. Okay, and I'm actually going to zoom a little bit out, and hopefully you'll still be able to see, because our sample space is actually going to get quite large, because we're going to take our ice cream flavors, and then, so we had 5 different ice cream flavors. How many sauces could we choose from? Because event 2 was we pick a sauce. So you went from event 1, where you picked your ice cream flavor, to event 2, where you picked a sauce. We had a total of how many? 1, 2, 3. 3 sauces to choose from, okay? Now we could go, we picked vanilla and raspberry, vanilla and pineapple, vanilla and chocolate. Oh, but wait a minute, we don't just have 2 events here. How many events do we have? We had 3. Now you need to pick your topping. Well, how many did we have to choose from? 1, 2, 3, 4. In event 3, we had 4 possible outcomes. So in event 1, we had 5 possible outcomes. Event 2, we had 3 possible outcomes. And in event 3, we had 4 possible outcomes. We could follow our sample space and we could follow our chart like we did earlier. And we could sit here and say, well, okay, I chose vanilla, raspberry, and nuts. So vanilla, raspberry, and nuts. Then we could go vanilla, pineapple, and nuts, vanilla, chocolate, and nuts. Oh, wait a minute. Now we got to go vanilla, raspberry, and sprinkles. We got to go vanilla, pineapple, and sprinkles. Vanilla, pineapple, or chocolate, and sprinkles. Do we really want to do that all the way down through this whole thing? How many possible outcomes of sundaes could you actually make? Again, those wonderful people who have figured out principles and laws that we can follow. We find with the fundamental counting principle, if we do 5 times 3 times 4, what do you end up with? Have a total of 60 possible outcomes. You could walk in and there is a possibility of 60 different sundaes that you could make with 5 ice creams to choose from, 3 sauces, and 4 toppings. 31 flavors. You could make a lot of choices. So using the fundamental counting principle, you can see if you multiply together the possible outcomes for each event, you get the total possible outcomes. So let's look at this one. When ordering a new Ford pickup, okay, when ordering a new Ranger pickup, the customer will need to decide the basic package by choosing first a color. And what do we have? We have 1, 2, 3, 4, 5 colors to choose from. Okay, so we have 5 colors to choose from. She will also need to decide if she wants an automatic or manual transmission. So for transmission, so your tranny, you have 2 possible outcomes, and whether or not she wants 4-wheel drive or 2-wheel drive. So what kind of drive do you want? You get 2 options there. Oh, one more option. How many different basic packages? We've got also a regular cab and an extended cab. So we have, what kind of cab do you want? There's also 2 options. So we could turn around and we could create our tree. What's event 1? Event 1 was our color. What was our possible outcomes? We had 5 possible outcomes for our color. What was the second choice that you needed to make? And your choices are your events. So the second event, your tranny, you had a possibility of 2. What was the next choice that you had? What was the next event? Well, you had to figure out what kind of drive you wanted. Was it 4-wheel drive or 2-wheel drive? So that was another 2. Then the last one, what kind of cab did you want? Well, that was another 2. So do we want to do our little tree in sample space where we go like this all the way down, or use our fundamental counting principle and go, well, 2 times 2 is 4, times 2 is 8, times 5 gives you 40 total possible outcomes. That's your fundamental counting principle. So let's look at another way you could do it. Well, you're flipping 2 coins. The description of the event, what are we putting together? Well, the first coin, we could get either a heads or a tails, so you have 2. Second coin is a heads or a tails, so you have 2. Well, here's my events. I have a possible of 2 here times the possibility of 2 here. Your total outcomes is 4. Let's go to flipping a coin and rolling a 6-sided dice. Well, flipping a coin, you can get heads or tails. Flipping a 6-sided dice, you could get a 1, a 2, a 3, a 4, a 5, or a 6. So you have 6 total possible outcomes here, 2 here. What is your total outcomes? Have a total possibility of 12. You can get a heads and a 1, a heads and a 2, a heads and a 3, a heads and a 4, a heads, a 5, a heads, 6. Do you see how that works? Fundamental counting principle figured out. If you just multiply together the total outcomes for each event, you can get your total possible outcomes. Sundays, just like our ice cream that we put together, 5 ice creams, 3 sauces, 4 toppings. What did we end up with? We ended up with 5 times 3 times 4, which gave you a total possible of 60. What did we end up with our vehicle? The color. We had 5 possible colors. We had 2 trannies, 2 axles, and 2 cab, which gave us what? A total possible outcomes of 40 choices. 40 different pickup trucks you could put together with that amount of choices. So that is the fundamental counting principle. Now, as you move forward, go and do the homework that is assigned with this. You'll find it on Canvas right underneath the video. See how you do. Email me questions. Don't forget to come to our Zoom classes. I will be going through the questions that are emailed to me, and we'll be answering any issues that you may have. You guys have a great night, and don't forget, we love these little shortcuts, these little principles, these little laws of math that make some of these really big, long things become short. Have a great night.